Hello everyone. Hello. Yes. Maika, can you hear me?
Yes, sir.
Okay. So last in the last session you joined?
No, sir, I wasn't there for the last session.
Okay, he wasn't there in the last session. Okay. Mm,
Sir, if possible, can you teach thermodynamics uh,
mm,
in short? Because that was a hard topic. Like my problem is that I'm not good at physics.
okay.
I'm not that great in physics. So
Okay.
what I'm doing is I'm learning the hot topics or the major regions which will help me score. So
So I will suggest that what I'm suggesting that don't try to pick any topic and don't try to do it from scratch now because your exam is just
yeah,
6 to 7 days ahead.
yeah.
Okay. So what I'm suggesting that if you are facing some difficulty or you can pick up some questions which you have done or something and you are facing difficulty, then you can ask me the doubts.
Okay.
Okay.
Yeah, yeah.
So right now it is not a good choice, not a better choice that to pick up a new topic up from scratch and then
I
uh,
do that usually, like
mm,
especially towards the end, I start forgetting. So study from scratch if I have doubts in those topics. That's why I asked you. It's fine, sir. I'll tell the questions only. If
yeah, if you are having some question, then you can very surely tell me.
okay, sir. Is
Uh,
there some topic which you're like teaching today, or it's just a DRS kind of session?
because yeah, I may teach some topic, but if I will suggest that because I will suggest that you raise some doubts.
Okay.
Hmm.
Okay.
Okay. Yeah. So if you are facing any doubt and anything you want to ask me, any topic or any particular topic, and any particular question that you are facing in that you are having some doubt in, then you can ask me. Okay. Okay. Afra, you have also joined. So, I'm asking you too. I'm telling you too that if you have some doubt, then you can ask me. For in the starting of the session, you can ask me doubts. So, if no question comes, then I will start taking some question by myself. Okay. So that's we are going to do in this session. So tell me, Afra, also please turn your camera on. Afra, are you there? Afra. Okay, so I will suggest that if you are facing some difficulty or anything you want to ask to me, any topic or anything, any particular topic, any particular concept that you want to ask me, I'm not asking that you raise some topic or some chapter from scratch. I'm not asking, but if you have studied some topic and you are facing difficulty in that topic, then I will suggest that you can ask me. Okay.
Sir, in the capacitance part,
Mm-hmm.
like there are few questions which I have doubt in. I'll send it to you, or like how should I copy paste the question?
Can you share the screen and show me?
Sir, 1 minute. I've stored it in a folder. That's what I'm so that is why I'm saying 1 minute, 1 minute.
Okay, okay, okay. See the folder. However, I'm suggesting you too that you should raise some questions if you are having some doubts. You to raise some questions, okay? If you are facing some doubts, then you can ask me. And you have to ask me now only, not I'm not asking for some other time. After you have to ask me now only, now itself. Hello everyone. Harshini, I guess you have joined the previous class.
No, sir, I don't think so.
You the previous session you joined. I remember.
Yeah. Yes, sir, I was the only one there, right?
Yeah. Okay. So. So I was just Mahika is just raising some doubts. So I'm just waiting for that. And in the timing, if you are also having some more doubts, then you can ask me. First, you ask me that those doubts, and then we will start doing some questions. If you are having some doubts, then you can.
Can you start with the questions?
You are not getting any doubts?
No, sir, I'm searching for my screenshots. It's just messed up. 1 minute.
Okay. 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 Rajini, you are having some? No, because previous class you were having.
Sir, I just need 5 minutes to just collect all the doubts.
Okay, sure. And in the timing, somebody else has joined? No, only three of you are there. Mahika and Hafra and Harshni. Okay, Hafra, you are not speaking something. Anyway, you are having some doubts. Can you ask anything, any concept or any topic? If you face any difficulty, you can surely ask me. So, okay, capital letters part you are taking, Mahika. Okay, so tell me guys, Harshni is searching something, so some doubts. Micah, have you found something? You find something?
Sir, I just sent one now.
Okay. Where did you send? On WhatsApp?
Yes, sir.
Okay. Okay. A calorimeter temperature falls to. Okay, now I am having some questions, so we can try solving them. Let me just open the notebook and then we paste the question. Just wait a moment. I'm just copying and pasting the question. Where is the why it is not getting pasted? Oh, this page. I don't know why the image is not coming. Okay, now it has come. Okay. Okay. So yeah. So guys, let me share my screen. Can you see my screen, everybody?
Yes, sir.
Okay. So this is the question first. First one. A calorimeter contains 10 gram of water at 20 degrees Celsius. The temperature falls from 15 degrees Celsius to 50 degrees Celsius in 10 minutes. When calorimeter contains 20 gram of water at 20, it takes 50 minutes water temperature to become falls to the water equivalent of the calorimeter. Temperature falls to in this case. Hmm. So guys, see. Have you read everybody, Micah and Hafra? Have you read the question? Okay. So in this, they are saying that a calorimeter is having 10 gram of water at 20 degrees Celsius. Okay. And its temperature falls to, and it was initially at 20 degrees Celsius, and its temperature falls to 15 degree in 10 minutes. in 10 minutes. Okay. So because temperature is falling, so we can say that calorimeter temperature is
Increasing.
no, temperature of the, see, we have filled the water in calorimeter and the water temperature is falling. Water temperature is falling. So we can say that calorimeter temperature is lower than 20 as well as 15. Because then only it can fall. Okay. So here it is given that it is falling in 10 minutes. So we see in this case, so we can say that heat that is flowing is depending on temperature only. Sorry, time only. Heat that is flowing from C. What is happening? Water is at 20 degrees Celsius, and let's suppose calorimeter temperature is T. Some T. Calorimeter temperature is C. Okay. And we can say heat is water equivalent of the temperature. Water equivalent of the calorimeter.
So can you explain water equivalent concept?
Water equivalent is this, that let's suppose see water equivalent concept I'm explaining. See how much heat this water that is present in the calorimeter, that how much heat it is losing. Can you tell me?
So can you please repeat?
I am saying that the water that is present in the calorimeter, which is 10 gram, how much heat it is losing. Can you
So 10
tell me?
grams multiplied by
Yeah.
specific heat
Specific
multiplied by the
heat
temperature difference.
multiplied
Is 20
temperature.
minus
So 20 minus 50. Okay, this much heat is losing. And because this is losing this much heat, calorimeter would be gaining this much heat.
Yes, sir.
So how much heat calorimeter gains is this water equivalent, mass of the water equivalent, that is in gram of the calorimeter into a specific heat of water and delta T. So we have just what we have done, that we have replaced this calorimeter mass with mass equivalent of water equivalent. So this is water equivalent. See how much heat it would gain. Let's suppose its temperature rises delta T. So mass of the calorimeter into specific heat of the calorimeter into delta T. This much heat it would gain, calorimeter, the container of the calorimeter. But we also say that it is gaining this much heat also. If this is mass equivalent of calorimeter, yeah, water equivalent of the calorimeter, and S of calorimeter water and delta T. These are equal. MC into SC into delta T is equal to MW, where mass equivalent, this is water equivalent of the calorimeter, into SW into delta T. So delta T and delta T gets cancelled out. So we are getting MC into SC is equal to mass of the water into S of water. Okay.
Yes, sir. Got it.
So see, now what we have to take in this question, got it? Tell me, got it or not?
Yes, sir. Till now I got it.
Okay, okay. So what we have to take, that delta T, temperature difference, is proportional to time. Okay, so we can replace this. So here what is we are getting in the left hand side? We are getting 50. This 10 into 5, 10 into 5, 50. And this is mass of mass equivalent of the calorimeter. Water equivalent to the calorimeter into specific heat of water is 1, and into delta T. And delta T is proportional to what? 10 minutes. So is the answer 5 gram? No, but then there's something wrong.
So 10 gram.
Okay, the answer is 10 gram. Okay, 15 minutes. Do you have the solution of this?
Yes, sir. Should I send?
Yeah, send me. Send me just quickly. Then I will check. Okay, now, oh, wait. For today's question, how many are there? Okay, maybe Mahika can also send me some papers, some question, isn't it, Mahika? Okay, okay. So I am taking first one for Mahika and one for. Okay, guys. So let me just copy and paste for the question. Okay. So this is the question, Mahika. Okay, you can also tell me by saying. Okay.
Yes, sir. Sir, I'm getting the wrong answer only. I know
Okay.
the method also, but still.
It is a Wheatstone bridge. It is a Wheatstone bridge.
Yeah, kind of. Yeah.
Kind of, no. It is a Wheatstone bridge. See.
Yeah, yeah.
Yeah, it is a Wheatstone bridge. So what will be the this 20 ohm would be neglected. This 20 microfarad would be neglected.
Yeah, so these
So
A and B
6
will
and yeah,
be
this
one.
C1 and C2 are in series, and C3 and C4 are in series. So C1 and C2 series means 3, and C1 and C3 and C4 series 3. 3 plus 3, 6. The answer should be 6. Tell me. Tell me. See, C1 and C2, yeah, C1 and C6 and 6 are in series, then the equivalent of DC, equivalent of 6 and 6. So this is the circuit. Every resistance is 6, 6, 6, 6. So 6 and 6 series, so it will be 3, and this 6 and 6 in series, it will be 3, and now they are 3 and 3 are parallel, so it will be 6. Okay. Okay. Okay, what did you do?
I considered 20 also in the circuit.
Okay, but it is a Wheatstone bridge. It is a
Yeah.
Wheatstone bridge. So this you have to see. Okay. Uh,
Sir, these kind of questions like the Wheatstone Bridge, I have not seen many in the mock test. So they don't usually come, or like very few come in the mock test.
okay, very few come in the mock, but they can come for sure.
Okay.
They can come. Okay, let me just take the next question.
Sir, I had sent the answer for the previous question. Could you please check that?
Okay, I am just checking. I'm just checking. Actually, and thus the next question is I'm raising because air capacitor of capacitance connected to a wall. Now the space between the plate is filled with a declared directly the charge that flows from battery to. Okay. So see, in this capacitance is 10 microfarad initial, and battery voltage is 12 volt. So can you tell me what is the charge is C into V on the capacitor? Okay. So what is the initial charge? Because initially no dielectric is placed. No dielectric is being placed. So initially what is the charge? Plus CV on this. It is plus CV on this and minus CV on this. Okay. Tell me. Okay. So the battery's voltage is 12 volt, and the capacitance is 10 microfarad. Okay. So this is plus CV and minus CV. And now what is happening? A dielectric is inserted. So when the dielectric is inserted, the capacitance becomes K times of the initial capacitance. Okay, so now the charge is K into CV minus K into CV. Tell me. Because when dielectric was not present, the charge was only CV. And now the dielectrics, we have filled the dielectric, we have filled the capacitor plates with the dielectric. So now the charge is K into CV. So see how much charge has been flown from the battery. Initially the charge was CV, and now the charge is K into CV. So how much charge has been flown from the battery? It is K final charge minus initial charge. So K into CV minus CV means C into V, K minus 1. So K is 5. So 4 into C, that is 10 into 12. So this should be the answer. 480 microcoulomb. Okay. Okay. Now tell me if there's some problem in this. Uh, water equivalent px. Okay, this is not a problem of calorimetry. Oh, okay. Now I got it. It is a problem of Newton's laws of cooling. Have you read that? Newton's laws of cooling?
Yes, sir.
Okay, so it is problem of that. Okay, I got it. So the thing is that, see, in this case, we have to assume that water is filled in the calorimeter. Okay, water is filled in the calorimeter. We don't have to see. Here the thing is that the calorimeter is having the same temperature as that of water only. So calorimeter temperature is 20 also, 20 degree. They are losing, both calorimeter and water are losing heat to the surrounding. Both calorimeter, this calorimeter container of the calorimeter and water are losing heat to the surroundings. This is what is happening. And see, let me just add some space over here. Yes. So see how the thing is that, and we know that dt by dt, rate of temperature change with respect to time, is proportional to temperature difference, temperature of the body minus temperature of the surrounding, temperature difference of the this. Okay, tell me, this is the thing.
Yes, sir.
Okay, so we can see that if we just take dt over this side, so dt is proportional to temperature difference, temperature of the body, and into dt. So if we integrate it, so it will be dt will be k into TB minus TS into dt. And if we integrate it, so because this is constant, if we take this as constant, if we take this the delta T as constant, so it is coming out delta T is equal to K into TB minus TS into delta T, where delta T is the time in which the temperature is falling and delta T is the temperature difference. Let me see how can we do this. So see, temperature is falling in this case from 20 degree to 15 degrees Celsius. Okay, so what is delta T now? Delta T is 5. Okay, and K. What is that? In this case, we can see because let's suppose surrounding temperature is TS surrounding temperature is TS, and temperature is falling from 20 to 15 degree. So we can, on an average, we pick the temperature of the body as 20 plus 15 by 2. Okay, so if on an average we pick the body temperature as 20 plus 15 by 2 means 35 by 2. So this, if we pick the temperature on an average, so we can take this temperature as constant only. So if this is constant and minus T surrounding, and time is delta T is 10 minutes. Delta T is 10 minutes. So this is first equation. And now the second equation is okay. Wait. In this case, they have taken. I don't know why what they have done. Maybe this question, where from you pick this question, because in this case they have taken that rate of heat flow dq by dt, dq by dt as proportional to temperature difference, proportional to temperature difference. But actually the Newton's laws of cooling is this: dt by dt is proportional to temperature difference. dq by dt is not proportional to temperature difference. dt by dt is proportional to temperature difference. So if we see, if we take it dq by dt is proportional to temperature difference, so here the term will come delta q. Delta q. Getting? Maybe. So delta q will come. So in this case, delta q is how much? Delta t, mc into delta t. So m is what? 10 plus x. C. C is 1 into delta t. Delta t is 5.
Sir, here why are we taking 10 plus x?
Because the whole mass of the body is 10 gram of the water is there, and water equivalent of the calorimeter is x. So the whole mass of the body is 10 plus x.
Okay, sir.
Okay. So this we are taking. So 10 plus x into 5, and next equation will form like 20 plus x into 5, because temperature difference is still 5. And this will become a minute calorimeter contain 20. So it will again become 13 by 35 by 2 minus ts into time is now 15 minutes. So from this we can calculate x. Two equation, two unknown. But maybe this is the wrong method, because actually the Newton's laws of cooling is that rate of temperature change is proportional to temperature difference. Rate of dt by dt is proportional to temperature difference, not dq by dt. They have taken dq by dt. So I'm not getting this. Okay.
Sir, is there another way of solving this without this method?
No, this is only the method.
Sir, so in case of water equivalent, do we use dq by dt and then solve?
Yeah, if this they have done like this, so we have to do it like this.
Okay, sir.
Okay. But generally we take only the body. Okay. So take it like this. Because here what is happening? So do it like this. Okay. Have you got this? Okay.
Yes, sir. I got it.
Next. Have you sent some more?
Yes, sir. I've sent 2 more questions.
Okay. Okay. Wait. The figure shown below shows the cooling curve of pure wax material after heat cools from A to B, and solidified B to D and L, C are respectively value latent heat, as specific heat of liquid, the ratio of latent heat and specific heat. Okay. So it is given. Let me just first copy and paste the question. Yeah. So see, in this case, temperature versus time graph is given. Temperature versus time graph is given. So A to B, A to B is that curve when the body, yeah. See, A to B is that curve when the body is in the liquid state. A to B, the body is in liquid state, and B to D, the body is solidifying. B to D, the body is solidifying. So here it is in liquid state. So when the at A, see, At A, the body is in solid state, sorry, liquid state, and as the temperature is falling, so body is going towards, because when temperature falls, when temperature falls, the body becomes solid. So here at A, the body is in liquid state, and towards B, it is solidifying because temperature is falling. Temperature is falling. Okay. And B to D is what? It is the in what is happening in B to D? B to D is because here in B to D, the body, both states of the body, like what liquid state and solid state, are coexisting. That's what happens. That's what happened. So this is what happened. This is happening. So see, ratio of L upon C. In this case also we can see that delta Q time is given. So delta Q we can take as proportional to T, proportional to delta T. So see, in B to D, how much heat is flowing? M into L. Okay, M into L. And that is proportional to delta T. Okay, so we are getting L as proportional to 4 minute divided by M mass. Okay, this we are getting, and then MC into delta T. This is see at B. At this point, it is just delta T by delta T. Heat flow. And C solid liquor, solid longer, and C are respectively latent heat and specific heat of liquid wax. Okay, specific heat of liquid wax. So here in this we can see. First, tell me what is the slope at this point. What is the slope at this point? So what is this slope? dt by dt. Slope is this much. dy upon dx. So here y is t and x is small t. Okay. So what is the slope in this case? 10 divided by 2 minutes. Okay, this is the slope. Okay. So dt by dt we are getting this, and okay, and AB is that curve times 2 minutes.
So from A to B, we can use MC delta T, right? Because in the question also specific heat of liquid wax is given. So maybe we have to use that.
But MC delta T with which we will equate that.
Can
Okay,
we equate the heat from A to B and B to D?
dt, MC dt is equal to Q, and we can also equate that delta T we don't know, but this we can have equated. But what is the time? Because Q is proportional to T, that we can assume. But what is the time here? We can assume that it is going from 90 to 80 in 2 minutes. Like this, we can assume, we can take
Yes.
90 to 80 in this 1 minute. So in 90 to 80 in 2 minutes. So delta Q is proportional. Have you just, do you have the solution of this?
Oh, yes, sir.
Okay, send me. Send me, then I will just check the solution. I'm not just wasting some time. Yeah, that's what they are assuming, that they are assuming that 90 to 80 temperature is falling in 2 minutes. They are taking that 90 temperature to 80 minute temperature is falling in 2 minutes. So heat is proportional to time. Heat is proportional to time. Okay, so so in this case, see, 90 to 80 temperature is falling in 2 minutes. So heat will be, let's suppose, Q in this case, and from B to D, the time is 4 minutes. So heat in this case from B to D would be 2Q. Getting this point?
Yes, sir. Because Q is
Because
proportional to time, so double the time.
yeah, Q is proportional to time. Q is proportional to time. So this we have to use. So if Q is how much? Q is MC into delta T. And 2Q is how much? 2Q is M into L. 2Q is M into L. And here delta
Yes,
T is
sir.
how much? Delta T is 10. Okay. From this we can do. Got it?
Yes, sir.
Okay. Uh, a man is standing in the fields, rate of drumming is generally increased. Okay, so this we have done. Let me just pick up another question. Maybe one more question is also there, no?
Yes, sir. The echo question.
Yeah, sure. Hmm. Yes, okay. The man standing in front of a hill beats a drum at regular intervals. So see, man is standing in front of a hill like this, and he is beating drums. The rate of drumming is generally increased, and he found that echo is not heard distinctly when rate becomes 40 per minute. Then he moves closer to hill by 90 meter. So he moves closer to his hill by 90 meter. This is the distance. Then first it is standing at 1, and next he moves to 2, and he again finds equal not when the drumming rate is echo is not. So what is the distance when the echo is not heard? Can you tell me?
Sir, in position 1, it's not heard.
Okay, but the time should be what there was a formula of the time. Time should be less than for echo.
0.1 second.
Yeah, maybe that also. Let me just check. It is given. Let me just check. For echo, time should be. Yeah, correct. 0.1 second. Correct. Okay. 0.1 second. So echo can be heard only. So in this case, it is just on the verge of hearing the echo. And at 40, when it is playing at 40 per minute and playing at 60 per minute. Okay. It is just on the verge of hearing an echo. Getting this?
Sir, how do you say it is on the verge?
Because he is increasing. He is increasing his drumming. He is increasing the interval of his drumming. So if he increases the interval of drumming, when the echo reach, in that time only he just make the second drum sound. So in that case, he will not hear the echo.
Sir, I'm not getting it.
Okay.
Sir,
Okay.
when it's increasing from 40 to 60, the time interval is decreasing. So is it like going more towards 0.1
No,
second?
see. Let's suppose he has just played one drum. He has just played one drum. Okay. First drum, one drum he has played. So how much time will it will, let's suppose this distance is x. So how much time will it take to hear the echo? It will take the here 2x by velocity of sound.
Yes.
And if in that time he plays the second drum, if in less than this time if in less than this time he plays the second drum, then he is not going to hear the echo. He will just hear this sound only, the drum, the sound of the drum, the sound of the second drum.
The sound of the first echo of the first one will not be heard.
Yeah, because if he just play this second drum when before the reaching of the echo. Get it? What I'm saying, he has placed the first drum. He has placed first drum. Okay. How much time it will take? How much time the echo of this will take to reach him? It will take 2x by bs.
Yes.
So if he plays second drum before that, if he plays the second drum before that, will he hear the echo? No, he will not hear the echo. So we have to just take that this is this time. This time is because he's playing 40 per minute. So in 40 per minute means 40 by 60. So we have to take this as 40 by 60. Because 40 per minute, so how much in second? It is once in 1 second. How much drumming is playing? What is the time interval between his drumming? 40 by 60.
Okay.
Getting?
Yes, sir.
In 1 second, this is the time interval between his drumming. 40 by 60, so means 2 by 3. So this is 2x by vs. And next, we have to equate 2x minus 90, because the distance is now x minus 90. This distance is x minus 90 now. So divide by vs, and that is equal to 60 per minute, means 1. So I hope we should get the answer. X divided by x minus 90 is equal to 2 by 3. And we are getting 3x minus 27 is equal to 2x. So we are getting as 270. 270 here we are getting.
Yes, sir, that's right.
Okay.
Got it, sir.
This is yeah, this is the good question. Okay, tell me more if you are having.
Just a minute.
Okay, Micah and Havra also, if you want to ask, then you can also ask. And if there is some doubt in these problems that we have discussed, then also you can ask. Okay, Micah, send me some. Okay, let me check. So I'm taking your doubts, Micah. Electric field at center O of semicircle of radius A have a linear charge density lambda is given us. We have to integrate this. The only way that we can do this by integrating. Do you have some means some? So do you have gone through some integration questions? Tell me.
Sir, yeah, but
Oh,
I
wait.
did not get this.
No, we don't need to integrate. Sorry. The formula is this. Formula of this is 2k lambda by r sine theta by 2. This is the formula of integral for an arc. See, for an arc, if we have to find if there is some, suppose there is arc, and if we have to find the electric field at the center, how we can find? We can find it that suppose it is subtending an angle theta. So the electric field at the center is how much? It is 2k lambda by r sine theta by 2. This formula we have to use. Okay, so here see, 2k lambda by r is a, and theta is how much? Tell me. Theta is this because this is Yeah, 3 does 180. So it will be 180 by 2 means 90. So it is coming out as 2k lambda by A. And k is 1 by 4 pi epsilon naught. So we are getting 1 by 4 pi epsilon naught means 1 by 4 pi epsilon naught lambda by A. So we are getting lambda divided by 2 pi epsilon A. Okay. Okay. So this is the formula base only. At first also, I also thought that this
Sir,
is of
because in the FT, like the paper of askIITians, it's the integration type question. I didn't know the answer for this. So in that, the solution is given in the integral form. Like, I mean, they integrated
okay.
it all. That is why I
Okay.
don't understand.
Okay. No, there is a formula for an arc. The formula at the center is this much. 2k
Okay.
lambda by r sine theta by 2.
So can you show the derivation if it's possible?
Derivation of this.
Like there are so many formulas we have to remember. So in case if it's
No,
an easy,
derivation, you cannot do the derivation in the exam. Surely you cannot do. It will take some time for me also. You cannot do it, is not possible. So remember the formulas. Because integration in the NEET exam you cannot perform. Okay. So you have to remember the formula. I can show you the derivation for sure. For this arc, I should show you. If you are willing, then I
no
can show
sir,
you.
it's fine.
Yeah, it's yeah. So okay, I've got some more. Because how many questions are there in your exam?
180.
180. So there are quite a lot of questions. So integral, if you do our integral, maybe half an hour is just gone into only single question. So that's you have to remember. See, very large plate are given charges in this figure. If the cross section area of each plate is the same, the final distribution on the plate is C. So this is given Q on this plate, minus 5Q on this plate, and 10Q on this plate. So C. If we consider that on this surface, on the outer, on this surface is X, so on this surface would be, tell me.
Minus 5x, right?
No, it will be minus X.
Okay.
It will be minus X. So similarly on this surface here, it will be minus 5Q plus X. And on this surface, it will be minus of minus 5Q plus X. And on this surface, tell me on this surface, wait, this surface, C. On this surface, it will be 10Q minus 5Q. Oh, wait, let me just write it somewhat bigger way. So these are the plates. So on the right side, this on it is Q minus 5Q and 10Q. Q minus 5Q and 10Q. Okay, so let's suppose on the right surface of this first plate is X. So what is the on this left surface? It is minus X. So on this, how much charge will remain? Tell me.
Minus 5 plus x.
Minus 5Q plus X, correct. And on this, X minus 5Q. Okay, and on this,
10,
hmm?
10q minus 5 plus x.
15Q minus X.
Yeah. Okay.
Okay, and on this Q minus X. Okay.
Okay.
So now we have to just do one thing. We have to find the value of X. So how we can find the value of X? We will just equate electric field inside the material of the conductor as 0. So let's suppose this point is A. So E at A is 0. E at A is 0. So it will, so from Q minus X, it is in the right direction. X in from X, it is in the, tell me, from Q minus X, it is in the right direction. From X, it is in the left direction. Right? Yeah. So let's see. So plus Q minus X divided by 2 epsilon naught. 2 epsilon naught would come in every case. Because sigma by 2 epsilon naught is the electric field. So 2 epsilon naught will come in every case. So I'm just writing only the charges, not writing Q2 epsilon naught. Okay, so it will be q minus x plus x minus 5q plus x. Or wait, we can do it like this also. See, electric field due to this x and this minus x would get cancelled out, and this 5q plus x and x minus 5q would get cancelled out. So only the electric field due to q minus x, electric field due to q minus x and due to 15q minus x would remain. Minus 15q plus x would remain. So it is coming out as, oh wait, something I've done wrong. X is getting cancelling out. How? What I've done wrong? This.
Sir, it's not getting cancelled out, right? Minus 15
Huh?
to minus x, right?
It is getting cancelled out. See?
Oh, because minus of mine. Okay, yeah.
What
But
we have done wrong? What we have done wrong in this case? How it is getting cancelled out? 15q minus x, and here minus 5q plus x. Oh wait, I have taken over x minus 5q. It will be x plus 5q only. So here I have written wrong. It will be x plus 5q. So here the answer will come tan q 5q minus x. It will come. But again it is minus q is coming. Tan q 5q minus x, and it will be minus 5q. So x is coming out as why we are not getting in this? We have already actually three very large plates. The cross section area of each plate, the final charge on the distribution on the plate C. Okay. Let us just do electric fields at this point as 0, at B point as 0. So what we are going to get? We are going to add minus 5q minus x means plus x, and q minus x again getting cancelling out. Why it is getting cancelled? Do you have the solution of this?
Yes, sir.
Like,
It's there in the FT. I'll take the screenshot. 1 minute.
okay. What am I doing something wrong here? Actually, it never happens. Why is it happening? Minus 5q plus x plus, oh wait, I am just doing wrong. It is minus x plus 5q. It is minus x plus 5q. So it will be 5q plus x only. Okay. It will be 5q plus x. So I have just went quickly by doing trying to do it very quickly. So I just done it wrong. So here 5q plus x. So it will be 5q plus x minus 5q minus x. So here we are getting 2x as 6q and x as 3q. So we are getting this. So here the charge is 2q and here the charge is 8. Okay. So maybe fourth option should be there. Answer should be fourth option. Correct, Mahika?
Okay, sir.
So got it? Got it or not?
Yeah.
So we have to just consider. I have just taken the wrong charges. That's why we are getting wrong answer. Okay.
Sir,
So
is there any other way to solve the same question?
this is an easy way. No, this is a very easy way. Just see, let me tell you some, like doing it quickly. What was the thing? There was Q charge, there was minus 5 Q charge, and there was 10 Q charge. Okay. So let's suppose on the right plate of this is X. So what will be on the left plate of this? It will be minus X. And what the total charge on the second plate is 5Q, minus 5Q. So what should be the on this surface, on the right surface? Tell me.
Minus 5Q plus X.
Yeah, minus
13.
5Q plus X. And what should be the, on this left surface?
Negative of this.
Yeah, X minus X plus 5Q, minus X plus 5Q. Okay. And what should be on the right surface? It should be 10Q minus 5Q means 5Q plus X. Okay. Now what we have to do? We have to just, because in the conductor net electric field should be 0. So let's suppose this point is A. On A, we have to just keep the net electric field as 0. So this X and minus X electric field would get cancelled out. This charge and this charge electric field would get cancelled out. So only the electric field due to this surface, the left surface of plate 1 and the right surface of plate 3 would remain. So it is how much? Okay, so this much. This is okay, and have we got some more question? Okay, one more question of sent, Hajini.
Yes, sir, I've sent one.
So it is given a theater of volume. This can accommodate 100 meters. The reverberation time of the theater when empty is 8.5 seconds. It does not fill with occupying the front half seat. The real time changes. Absorption coefficient of each visitor. Okay. Actually, I also don't have idea about this absorption coefficient, but I'm checking what can be the answer. How we can do it. Average absorption coefficient. Reverberation is okay. Okay, the thing reverberation is what? Hearing those of the sound again and again, like echo, like echo only. Okay, so in this case, what is happening? 100 is the length of the theater, and 40 is the width. So here the picture is playing. Here the picture is being played. Here the picture is being played. This is 40, and this is 100. Okay, and the person are sitting up till here in the front half. Persons are sitting in the front half. Getting? Okay. So what is happening in this case? 500 visitors are sitting. So we can say, we can take on an average that every visitor is sitting at it at this distance, at 25-meter distance on an average in the between. Okay, can we take this?
Why are we assuming that?
Because we have to find the average absorption coefficient. So in this case, see, if the picture is being played, so reverberation time is 8.5 and the theater is empty. Okay, so means what does it mean? That okay, can you send me the solution? Do you have the solution?
Yes, sir.
Okay, send me just quickly. Then I'm not thinking it. Okay. Volume record word one visitor is 1000. Volume record word one visitor is 100 into. Oh, they have just applied some formula. You can just remember it. They have applied this formula only. There's no logic in this. Okay. So I'm not seeing any logic. You can check with the formula only. You can go with the formula. If I've seen some logic, then I will message you. Okay. There's no some logic is there. Some the formula of average absorption coefficient they have applied. Okay, tell me anything else? Arshini, Maika, Afra.
Sir, in Waves chapter, there's a type of question which involves the echo. There'll be a cliff. There's a guy that is moving towards the driver of a car moving towards, and he's honking the thing. And then the time, the frequency, apparent frequency heard by him
Yeah,
is the
sure.
question. There are two different methods I've seen. In one formula, the velocity of the observer is taken into account. In the other formula, it is not taken into account. Like, is there a difference between the two?
Okay, if you want to solve this type of question, you can you can have another session with me. I will just solve this type of question because this is Doppler effect questions. Okay, in maybe in half an hour, I will just get you acquainted with these questions. Okay, I will take mostly near about half an hour because it is easy also, and you can learn it quickly also. Okay. So so you can tell support or ma'am have another session in maybe in half or 1 hour. I can just complete this one.
Yes.
Okay. So okay, then tell me, Arjuni, Maika, you have some more? The time is just about to end. Okay. Okay then. So anything else you want to ask, Arjuni and Maika?
No, sir, that's
Okay, so what I'm suggesting, if you want to, because they are easy questions, Doppler effect. You can do it. You can do it very quickly also. You can do it very quickly. So if you want, then you can have a session with me one more time. Then I will just tell you about this type of I will just tell you how to solve these type of questions. Okay, if you are facing problem.
I'll send a mail to support.
Okay, sure. Okay
Thank
then.
you, sir.
Bye, all of you.